Hey everybody, welcome. And I want to talk to you about the average atomic mass here and how to do some simple calculations with it. And it all stems to what you see on the periodic table. When you look on the periodic table and you look at masses, you can see that sometimes it's a whole number, like helium seems to have the number 4.0, but sometimes it's not a whole number. Vanadium is 50.94, copper 63.55. And so when we look at not the atomic number, but the atomic mass, what we're finding is those mass numbers represent something slightly different. Those mass numbers on the periodic table are the average atomic mass, which means it's the weighted average of all the naturally occurring isotopes of those elements found in nature. So how do we get a weighted average? That's what this calculation's about. How would you think about that? Well, the way to think about it is get the mass of the three isotopes, and we see right here, oxygen has 3 naturally occurring isotopes. The most abundant by far is oxygen 16, and it has a mass of slightly less than 16. And that's because if we look accurately at the masses of protons and neutrons, we told you that they are exactly 1.00, but they're slightly different than that. So this is an accurate measurement. AMU stands for atomic mass units. So if we look here, we should assume that most of the oxygen in the universe has this mass. But there are some heavier forms, oxygen 17 and 18, that we can measure and detect. Notice their abundance isn't dramatic, but it does exist. And since there are heavier isotopes, the weighted average has to be a little bit higher than 15.9949 because there's heavier isotopes out there. So the pattern is to take the mass of the isotope and multiply by its abundance as a decimal. Do that for each isotope. Isotope 2 and its abundance times a decimal. Isotope 3 times its abundance as a decimal. Add that all together, divide by 100, and you should get the weighted average. On our periodic tables, we round it just to the hundredths place, and that's what we're seeing. So let's set that up. I would want to take 15.9949 times its abundance written as a decimal, 0.9976. Notice I moved the decimal 2 places. I want to add to that the mass of this one, 16.9991, times its abundance. I got to move the decimal 2 places. That's a lot of zeros, 0.0004. And finally, the third isotope in this equation would be the 17.9992 times its abundance, 0.0020. And that should give me a number. And I can just do that on my calculator, right? I can, on my calculator screen, let me kind of show you this right here. I can turn on my calculator and just kind of go through and do this. So 15.9949 times 0.9976 plus 16.9991 times 0.0004 plus 17.9992 plus, go back 9 times 0.002 and just hit enter. Notice that number I get, 15.9993. That is the mass, 15.9993. That is the average atomic mass. Notice it went slightly up because, well, there's heavier isotopes. On the periodic table, we typically see it as 15.99 or 16. So hopefully you understand how to do that, and we'll do well with that. Thank you.